Okay, we have a temperature controller which is an TOHO brand. It's TTM-J4, and here we can see the wiring diagram. And this side you have the connections. Okay, this is not powering up actually, so I have taken it apart to see what's going on inside. Okay, inside we have two PCBs. It's like there are two parts. We have the, I think, the controller IC part where all the control is happening, and this side we have the power supply part. So I have checked it earlier, and here let me remove this one, and we have a switch mode power supply here, and in this from the back side these two terminals will be connected to this power supply part from number 5 and number 4, and from that it will come to this rectifier, and then it will convert it to DC, and from that it will go into this capacitor, and then to this control IC. So I have checked this capacitor, and it was the capacitor which it had was 22 μF 1 400 volts, and it has decreased to around 10 μF. So I have changed it with a capacitor which I had with me. So I have put 350 volt 15 μF capacitor now, but it didn't power up. So I checked, and then noticed that this line filter, this coil is burnt. It is connected in series to this AC path. So after that it will go to this rectifier. So it has burnt. So I think that's because there was a high current consumption or high current situation has happened in this switch mode circuit. So I will check this control IC first. It's MIP 0221 SY IC. So it has control, source and drain here. So I need to check whether drain and source has the proper resistance. It means that it should not be connected in any case. If there is a resistance, it means it's somewhat short. Then take the multimeter and check the resistance of drain and source. So it shows an ohm value, so it should not be like that, and it means there's some problem with this control IC, switch mode IC. So let me see whether I have a compatible one, and let's check. desolder this thing. Okay, here's the control IC which I have removed from this board. So we have control pin here, and then source pin here, and the drain pin here. So the source and drain should not be connected in normal condition. So we'll check again the resistance. So it's about 0.5 kilo ohms, so that's pretty low, and I think it's shorted from inside. So I have another compatible IC because I don't have that one with me. It's a TOP203YN. It's a compatible one, so we'll see about its resistance. It's a new one, and same pin arrangement. So between source and drain we have around 35.5 mega ohms. So that should be the normal value because it should not be in a shorted condition. And yeah, we are good to go. Okay, I have cleaned these holes from inside and out, and you can see it shows the pin signs: control, source, and drain. So, and I put back the new IC. So this is the data sheet of MIP0221S5 which I have removed from this circuit, and you can see that the pin arrangement 1, 2, 3, and in one you have control, then source, and then drain. And when you check the currents, the output current of 221 is 0.3 amperes. So let's see about the TOP203 I have inserted. So this is the data sheet of TOP switch family, and in 203 you have 4270 watt output, which was 95 in 221, and then here you have this pin arrangement: control, source, and drain, which is the same as 221. But the current limits of 203 TOP203 is the self protection current limit is 1.5 amperes minimum and 2.1 amperes maximum. So it's pretty much compatible with the circuit. So this is the basics switch modes power supply circuit arrangement. This is for TOP, but it's similar to that 221. So we have the supply, AC supply, or it can be DC supply, and this is the line filter, and you have the rectifier here, and after that you have the main capacitor. This is 47 μF here, but it was 22 μF in our original circuit. And then you have this control IC. So this is the starting capacitor. So this capacitor should be in proper value to start up this switch mode circuit. So then after the DC transformer, it will produce whatever the voltage we need according to the feedback circuit. So that's the technical information about this switch mode ICs. So I told you earlier about this line filter. I checked earlier, it was not passing. Let's see. Yeah, it's open. It was this side of the rectifier is not getting any contact, but this side is not. So we have a problem with this line filter. So I'll remove it and solder a fuse instead, because this has also acted as an fuse. That's why it was burnt. And then I remove this line filter and solder a fuse. So I have removed this line filter, and here I have got a bus fuse of 1 amperes, because this is a tiny place, so I cannot solder a glass fuse. So I have found this from my computer components, and I solder it here. Okay, here it is. It's good to go then. Okay, let's check whether we have a connection now in the supply side. So now we have a connection here. So the supply side is okay, and the control side is also okay. So we'll see whether it's working or not. Okay, then I have assembled it again, and I have connected my supply to number 5 and 4 as it indicates in the diagram here, and let's see whether it's working or not. Let's supply. Yes, you can see now it has started. This was the setting. It was set in earlier, because I have removed this from a control circuit. So currently we don't have any temperature input here, so it's showing as this. Okay friends, it seems we are good to go, and see you next time.